We're going to turn to an obscure topic I doubt any of you have ever heard anything about before. Artificial intelligence. It's rarely been in the news, and it's not been much of a topic of conversation. I jest, of course. It is everywhere, and there are deep and profound issues around it, both in terms of the R&D enterprise, but its potential implications for society and culture, for economic competitiveness, and for national security. And what we're going to hear today is a description of NSF's role and its engagement across AI. We've got a couple of folks who are coming up, Tess and Michael, who will speak to NSF's activities and role in the future of AI. And talk about some of the successes and opportunities, but also some of the challenges. I'll just opine as they're setting up that, as you know, the NAIR pilot is launched. One of the great challenges with NAIR is actually access to AI hardware. It's in short supply. And it's very expensive, and that is one of the enablers for basic research in AI. So there are challenges as well as opportunity. That great sucking sound is talent often leaving academia to pursue opportunities in the private sector, and interesting opportunities at that. So those whole set of issues around the federal role in AI is deeply tied up with the CHIPS and Science Bill as well, because semiconductor access and national security issues are a deep part of that. And so I'm going to hand the floor to Ponch briefly to introduce our two commentators, and then we'll have a chance for some discussion. So welcome to you, and over to you, Ponch.
Thank you, Chair. I'm thrilled to have this amazing leadership in AI at NSF and at various levels across the agency. And Tess Planck-Knowles, she was at OSTP, and we're fortunate enough to have her back at NSF. She's a pioneer, she's a leader, and you have her bio. But I want to say that she's been doing a tremendous job in terms of making sure that all of the activities of NSF around AI is, appropriately coordinated and represented in the conversations that we have, both in the Hill as well as in the administration in the White House. Because of the executive order of the president, we're making sure that we are keeping true to all the deadlines. And in fact, you're going to hear about the NAIR pilot, which was 90-day, sort of an outcome that we had to put together, and you'll hear about that. And there are many, many things like that. And she's keeping a close coordination of all of the things that we're doing in AI. So I'm very grateful to Tess for doing a great job as a leader. And then Dr. Michael Littman, again, came to us as a program officer, and then now division director. And he's been doing a phenomenal job leading all of the efforts in AI. And he came to us from Brown University. And Michael, his own area is in AI. And therefore, it's nice to have people who represent that area, but also are the division director of the Information and Intelligence Systems. And he's been doing a phenomenal job trying to see how we can inspire more of the AI Institute thinking, expand AI, and a variety of AI programs through the Science Directorate and partnering with other directorates in advancing the AI priorities. So they have, and of course, the AI education programs. We have monthly, once in every other week or once in 3 weeks, we have AI sessions with us, and they do a phenomenal job in terms of showing their progress. Okay, over to you both.
Thank you. And thank you for the opportunity to join you today. Obviously, this is a topic that we love to talk about. So the goal of our presentation today, which will walk you through some brief slides, is to provide an overview of the many ways that NSF is supporting AI research, education, and innovation nationwide, and then how we're also integrating into some of these government-wide initiatives. So I'll pass it to Michael to kick us off.
Thanks, Tess. Oh, I should advance the slide. So the chair made a joke about how AI is sort of everywhere all at once right now. It was not always so. If one had not been paying close attention, it would seem that AI just sort of appeared out of nowhere. But in fact, AI research has been going on for many, many decades, and NSF has been investing in AI research for 6 decades. And I want to say a little bit about the things that we're seeing today and how they connect with NSF investments of the past, because I think that's actually really important, and it's not always so visible. So first of all, I want to mention that when we're talking about AI, what AI of today really consists of 3 major ingredients: people, data, and algorithms. And NSF has made substantial contributions to all 3 of those. one of the topics that I think is at the front of a lot of people's minds these days are these amazing chatbots that can talk like people, even though they're clearly not people. These are built on top of a whole bunch of technologies that NSF has been investing in: reinforcement learning, neural networks, large language models, just basically language technology more generally. These go back, some of them to the 80s and before the 80s. And I want to point out that it's really in the coming together of all these ideas that we get these chatbots that are so fluent and so capable of actually conversing with people. And just to remind everybody that they're really good talkers. They're not actually good thinkers so much. And so let's make sure that we don't depend too much on them to make decisions for us. But they're really a wonderful interface, a wonderful machine translator of language into something that's digitally processable, which I think is really, really cool. But really that's not the only very exciting thing that's happened in the last few years in terms of artificial intelligence. Another topic that I want to mention is AlphaFold, which is a system that, if you're not familiar with it, it comes out of the DeepMind company, and it predicts protein structures based on amino acid sequences. And that's kind of a remarkable thing to be able to do. People have been working on that problem for at least 50 years. And it's finally been cracked. And I think a lot of people out in the world view that as a great contribution that industry has made to the sciences. And I don't think that's incorrect, but I think they often ignore the fundamental work that goes behind it. This, again, didn't appear out of nowhere. The computational biology methods and the AI methods that actually are built out of, that AlphaFold is built out of, were supported by NSF research for many, many years. The lead author, in fact, of the AlphaFold paper was trained in an NSF-supported lab at the University of Chicago in chemistry. It's also worth noting that the key ingredient that really made that whole system possible is that it was trained on a protein data bank. Now, without that protein data bank, none of this would have happened. They did a lot of interesting other work, but really that's the linchpin that really made this possible. And NSF has been supporting the protein data bank since the 1970s. Like, this research would not exist if not for substantial input and investment from NSF. One other topic I want to mention is trustworthy AI, which I think gets a lot of play these days in the press and in policymakers' perspectives on AI. And this is actually a much more recent topic. The socio-technical analysis really kind of came into its own in the mid-2010s, so much more recently. And NSF has played an incredible role in supporting the community that really has brought those ideas to people's attention and really started to form them in a way that has had substantial effect on the conversation, including the Fairness and Accountability and Transparency Conference, which is kind of the main academic conference for studying these kinds of topics. All the founders are NSF, have received NSF support for the kind of work that they do. And finally, I wanted to mention recent contributions in education, things like the Duolingo system, which is really exciting. There's AI throughout that whole system, and the Duolingo and the people who created it were all NSF supported at one time or another. So if AI has been such a big thing for so long, what's different now? Why is it suddenly a topic of conversation? Is it that people just discovered it recently, or did something change? And in my thinking about this, I think there's really two major things that have shifted lately, and it's worth really thinking about them and their implications. So the first one is the implications of scale. So what people discovered is that if you add enough data, compute, and algorithms and run them long enough, you can actually shatter expectations for very, very difficult problems that people have been working on for a long time. So examples include speech recognition, image recognition and image generation, language processing, and the DNA example that I talked about previously. None of these, like all these were problems for quite a long time, and they've all completely shifted in terms of the ability for people to solve them as a result of scaling up algorithms that mostly we already had. So this raises interesting scientific questions, like what are these networks even learning? And how can we characterize what they learn and harness it? Right? We don't just want black boxes that can solve our problems and maybe sometimes not solve our problems, but we really want to understand scientifically what's going on here. Now, the challenge here is that to study something at scale requires much larger, if you will, microscopes or even telescopes than what we've had to date in the field. And so to study the implications of scale, it's not something that a single researcher can just do on his or her own in the lab. It really requires major investments to have the resources to be able to run these kinds of studies. So NSF's response to this has been, for example, putting together the AI Institutes. That's been a great opportunity for people to look at the connection between these scaled up AI problems and various kinds of use-inspired applications. But I think, of course, the major response that NSF has made is in terms of the NARE, the National AI Research Resource, which the idea of which is to make sure that researchers who are doing this kind of fundamental work have access to that scale that they need to be able to do the studies that are required to understand these systems. I mean, you're going to be hearing more about the NARE and the NARE pilot, so I'm not going to focus on this now. But I did want to mention some other things that are just very briefly that are not so visible but are really important, that we're seeing more and more proposals to, for example, my division, my directorate, in the form of community infrastructure proposals. Now, this maybe doesn't sound so surprising. We heard earlier about the Antarctic station. This is a major piece of infrastructure that has had a tremendous impact on people and science. But for some reason, other computer scientists haven't really engaged in that kind of infrastructure investment activities in the past. And so we're starting to really see a cultural shift in the AI community where we're saying, oh yeah, we need each other. We need to work together. We need to obtain larger resources to be able to do this kind of work. So that's one major component. The other thing that has shifted, that has really changed the conversation in AI, is the problem of managing the socio-technical boundary. So the idea here is that, again, people have been studying AI for around 75 years, one way or another. What's new now, one of the things that's new now is that there's been success in the lab, that we've actually solved some really interesting hard problems, and people have gotten excited and put them out into the world. And what we discovered is that there are complex interactions with people and institutions when you bring this technology to bear on a broad scale. So things we're seeing include methods that seem to do great in the lab, 99.9% accuracy, that actually fail dismally on subpopulations, particular underrepresented groups. Algorithms that exhibit biases in various ways, again, that seem to do great in the lab, but then when we actually apply them to real data and have them interact with real people, bad things happen. And new kinds of security concerns, right? So new ways that people can, who wish to do harm, can actually attack these systems and undermine them. So there's some really deep and important scientific questions as a result. How do we bring societal perspectives into this kind of research, right? Again, traditionally, you get a person, a couple people, a computer, a little bit of data, and you can do research. Now you really have to be thinking about things much more broadly. You need a systems viewpoint, that what we're talking about here is not just an algorithm, not just a mathematical abstraction, but an entire society and the way that society is impacted. So this brings various kinds of challenges up. For example, it's, again, a kind of scale. There's an implication of scale, but it's a different kind of scale. It's a scale that we get when we're actually applying these systems to across a broad group. And to do that, we need multiple disciplinary perspectives, which means we really have to change the way this kind of research is done, and therefore the way that this kind of research is funded. NSF's response to this include things like, again, the AI Institutes, but also, as Dr. Punch pointed out, the central role of partnerships. Right, that we actually have to work together to solve a lot of these problems. They can't really be done by independent investigators. And we're starting to think about maybe just putting together new kinds of test beds. So whereas traditionally in machine learning and artificial intelligence, we can actually study a problem by running a data set through it and reporting accuracy measures. If we're really interested in this socio-technical boundary, we need to measure things about the impact of the technology on people. And that means the experimental setup has to include groups of people and how they're being influenced. And so that really requires a different perspective on how we test these algorithms. And again, I think NSF can help with the response to that. All right, so I want to say a little bit about the overall strategy, about the way that NSF has been thinking about investing in the AI of tomorrow. So really, NSF is thinking about the broad spectrum of ways in which the technology can be designed kind of from fundamental first principles through thinking about issues in trustworthy AI, where you're thinking about the implications societally, thinking about ways of applying AI to solve particular societal challenges where the AI isn't the focus, but the challenge is the focus, and AI is the mechanism by which it could be addressed, all the way through how these techniques can be translated, these research breakthroughs can be translated into impact on the world and companies that support them. And cutting across both of those include supporting access to research infrastructure, like the NAIR, but other ways that we're supporting infrastructure, and developing the AI workforce of the future, so educational topics as well. So I just want to mention two programs before I kind of finish with this part of the presentation. One is, I mentioned several times, the National AI Research Institutes. I'm sure that this has been talked about before, that you've thought about it before. In the year and a half that I've been at NSF, this program has grown to 25 multi-organization AI institutes and roughly a $500 million investment to advance fundamental and use-inspired AI. So this is really exciting. And a lot of times when we're approached about, well, what are we doing in such and such area of an AI? Have you thought about this particular topic? Invariably, we can point to some aspect, something that's happening in one of the AI institutes where this problem is being addressed. They're really doing a fantastic job. And so it's been about, I guess, 4-ish years since the first AI Institute was announced. And we're now that some of those earliest institutes have been around for a couple of years, and we're starting to see the kinds of breakthrough research that they're doing. And it's just so phenomenal. We got to see them this past September. All the institutes, representatives from all the institutes came, and we had a Hill Day where we actually presented what the institutes were doing to representatives on the Hill. And it was just heartwarming just to see how fantastic the work is, how excited they were about it, and all the positive impacts that they're having on the basic sciences, on education, on agriculture, just all these really great and important problems. Especially when you hear in the news, a lot of times people like to talk about lots of gloom and doom topics around AI. It was just such a nice antidote to that, to see people really think about it. Oh, is that a question? Yeah.
Yeah, is that $500 million is over what period of time?
That's a good question. I don't think. Yeah.
It's a 5-year investment.
Yeah.
Each of the institutes is a 5-year-long investment. So that's what we have is each institute is $20 million scale. We have 25 institutes at $500 million. NSF has invested for equivalent to 15 of them, that is $300 million. The other $200 million are through our partners, interagency partners. For example, USDA invested in 5 of them, $100 million. All 5 of them are ag institutes, AI institutes. And then a consortium of industry, Microsoft, Google, Accenture, and Intel put in $20 million equivalent. So like an AI institute equivalent. So we have Department of Transportation, all the agencies that you would think that would be a partner are all partnering in this. Yeah. NIST has got a special institute.
Is it a good thing or a bad thing when your boss knows so much about what you do?
It's a fantastic thing. He's very engaged in all aspects. Speaking of which, another topic that he probably knows about more than I do is the recently announced NSF Regional Innovation Engines program. So we've heard about that a couple times today already, but I just wanted to focus on one particular aspect of it, which is that the 10 inaugural NSF engines, 7 of them actually focus on applications of AI. And if you look at the titles of them, it's not so obvious that things like water and climate and aerospace, energy, these aren't AI topics per se, but the way that these teams are actually trying to address these extremely hard problems is making sure that AI concepts are kind of threaded through the entire structure of what they do. So just as a quick example, the Illinois-based Great Lakes Water Innovation Engine is about developing intelligent water resource recovery systems. And so the way they're doing that is by leveraging leading AI capabilities to support sustainable water-intensive industry, right? So it's helping them make their decisions. They're including AI kind of in all aspects of the way that the system is designed. The North Dakota Advanced Agriculture Technology Engine on sustainable agriculture actually combines advanced sensor technologies so that the machines can actually see what's going on, crop and genetic data so that there's something to process, and AI and climate modeling technology to actually bring those to bear to make better decisions about sustainable agriculture. So this is all on top of the NSF Engine Development Awards, which were issued last spring to help regions prepare to apply for full NSF engines. And among those proposals that were considered, 15 of them focused on AI applications. I think it was about a third of them in some way just had AI as a core topic. So what I'm going to do next is turn it over to Tess, who's going to talk about infrastructure, education, and broader government engagement. Thanks.
Thanks, Michael. So as Michael mentioned, as part of that kind of holistic support of NSF for the AI innovation ecosystem, we support the foundational elements that we really see as kind of powering that discovery and innovation process. So in terms of the infrastructure, we play a really central role in connecting researchers to those resources that they need to fuel AI research. Michael talked about them in terms of the data resources, the computational resources, obviously the algorithms, and then the talent as well. And we've seen with the advent of machine learning, access to high quality data sets and the computational resources is really defining the ability to work at the cutting edge. And so we're starting to see this growing divide between researchers in the private sector who have access, particularly to the computational resources that they need, and researchers in academia and small businesses who don't always have the resources to really work with today's large models. And so because of this, one of our flagship efforts in this space is the National AI Research Resource, or NAIR pilot, which we were directed to stand up in the recent AI executive order. And we just launched at the end of last month. So I know you're going to get an opportunity to talk about it further, so I won't go into much detail now. But I will note that this pilot, which is a kind of a first step towards a national infrastructure that would connect researchers to these data, computational, and training resources, it really builds on prior work we have in this space. So NSF funded the Cloud Bank pilot, and this is a pathway for SAI's directorate researchers to access computing resources across a range of commercial cloud platforms. We also have funded the NSF Frontera supercomputer. Hundreds of US researchers access the supercomputer each year, and it's actually specifically equipped to accelerate AI and machine learning research. On the data side of things, one of the interesting programs we have underway is around developing a prototype of an open knowledge network. This is actually a partnership with 5 other federal agencies, and it's focused on developing integrated knowledge graphs based on publicly available data that's provided by the agencies, really to kind of mirror the knowledge graph technology that private sector has to develop advanced AI applications and consumer applications. And of course, the other critical foundational element to all of this is talent. So we are supporting the cultivation of this, broader AI workforce, from K through 12 education to experiential learning opportunities to access to advanced degrees. And what we're really focused on is advancing AI expertise and knowledge at the many levels that we see are going to be needed to integrate AI into society and into the workforce. Yes, sir.
Well, beside the workforce, as folks start to develop these large language models, what institutions are you engaging in terms of the research side of this, in terms of to make sure that these language models are diverse in their inputs?
You do want to talk about that?
Yeah, so maybe not so surprisingly, the flavor of proposals that we've been getting in the last year has shifted dramatically. As the researchers have realized, hey, this is kind of an exciting topic. There's a lot we can do with this. We're seeing proposals from the entire research community on topics related to language models. We're also looking particularly at how we can help support the development of large language models that are open, that where we can actually understand all the inputs that went into them. A lot of the work that the research community is doing now is built on top of things like either Llama from Meta or on top of ChatGPT from OpenAI. And we don't actually know what data went into any of those.
Yeah, well, my question is more direct in the sense of what institutions, HBCUs, MSIs, not just workforce, because that's one piece, but are also involved in the research that is going on. Are you funding any currently now under your current awards?
I will have to get back to you on the particulars there, but
if I can mention, I think one kind of exemplar program we have in this space is the Expand AI program. And this actually leverages that network of AI research institutes and pairs MSIs with these institutes to build their AI research and education capacity. So it's really about leveraging what we already have there to build the capacity across diverse institutions to not just educate the workforce, but really to be involved in the research side as well.
Vic, one thing that I want to add is all the 25 AI institutes have outreach components In fact, one of the AI institutes in the Southeast, Tuskegee, is a partner. So we find that number of these AI institutes have partnership with K-12 institutions, minority serving institutions. So even over the last 4 years, we have expanded how we have touched the training and skill development in AI through the AI institutes, in addition to the new Expand AI program.
Could you tell me more about K-12 education?
Yes, absolutely. And so we actually just in December launched an Educate AI initiative. And this is, again, kind of fulfilling some of the mandates in the AI executive order that's intended to enable educators to bring educational opportunities into their classrooms. We're starting with K through 12 and undergraduate, and then we're going to be expanding to community college and reskilling initiatives. And this Educate AI initiative builds on prior work that we've done in this space. And so through our AI for K-12 initiative, we funded the creation of AI educational standards that are accessible to educators across the nation right now. And this initiative also funded training resources for educators and kind of exemplar work plans that they could bring into the classroom to start to really integrate AI into their curricula. And we're intending to expand on this work going forward through the Educate AI initiative. I'll also mention one of our new initiatives to provide experiential learning opportunities. So to provide an opportunity for folks at kind of whatever level they are in their career to experiment with an AI career path. And so this is through our newly launched Experiential Learning for Emerging and Novel Technologies program that it covers all technology areas but has some focus on AI. And then, of course, in this kind of broader workforce and education space, the longstanding Graduate Research Fellowships Program and our newer CS Grad for US program are making graduate studies in AI available to more students across the country. And so, of course, as we've been moving forward across those pillars of investment, we've been doing so in the context of increased attention on AI from policymakers. And this is both from the White House as well as Congress. So we've mentioned this, but in October of last year, President Biden signed the executive order on the safe, secure, and trustworthy development and use of AI. And this built on prior administration work to develop a blueprint for an AI Bill of Rights, as well as NIST's work to develop an AI risk management framework, and really represents a comprehensive approach in terms of the federal government moving forward on AI, in terms of managing risks, but also harnessing opportunities. It is so comprehensive that's actually the longest EO in American history, as we heard from our White House colleagues. And if you dig into it, it is quite comprehensive and long. So there's several key goals in the executive order. There's really a strong focus on how we can protect Americans from risky models and risky uses of those models. It's a lot about supporting workers, both in terms of the integration of AI into their workplaces and then as they build the skills to interact with AI in a future AI-driven economy. And there's a focus on how we can figure out how to use AI to solve problems for society, and that's a big space for NSF to play in, as well as how to strengthen the government's own ability to integrate AI into operations to more efficiently and effectively achieve agency missions. And then expanding AI talent, both in terms inside of government, and there's a big focus on this AI talent surge that was directed in the executive order, and then in the broader ecosystem. And again, that's where NSF has a clear role to play. And of course, there's a strong focus on safety, testing, and validation of AI systems and advancing the science and standards to do so. So NSF has several tasks in the executive order that are very much tied to the role that we play in supporting research, regional innovation, and building the education and workforce opportunities. And you can see those listed here on the left. And they all build on work that we have underway, much of which Michael and I have touched on already. And we're also in a supporting role for several tasks, so such as that led by Commerce around developing test beds for AI, and Michael talked about some of the ways that we're thinking about that, as well as working with DOE to expand opportunities to train scientists in AI. And then we're working closely with state and USAID as they develop a global AI research agenda. And so in addition to this increased attention from the White House on kind of moving forward holistically on AI, we've seen increased attention from Congress on AI-related issues. I mean, this is really intensified, I think, probably the past 2 years. And so in the Senate last fall, Senator Schumer led a process to hold a series of what were called AI Insight Forums. And these brought together diverse speakers, so tech leaders, former government officials, academics, civil society representatives, to really talk through some of the key issues in the AI environment right now. So from risk to innovation, workforce, role of AI in democracy and elections, and privacy and liability. And this was really intended to kind of set the foundation for future legislation. And then, as the chair mentioned, just yesterday, the House announced the launch of the bipartisan AI task force to start a similar process on the House side. And so we've, fielded a lot of interest from our colleagues in Congress on issues ranging from the NAIR pilot. There's a lot of interest there, as well as AI education, AI and cybersecurity, these kind of connection points between AI and semiconductors and cybersecurity. And I actually had the opportunity early this month to participate in a hearing in front of 2 subcommittees of the Committee on Science, Space, and Technology that was focused on the topic of AI and driving scientific innovation, but really heavily focused on the NAIR pilot and the pathway to a full-scale NAIR through the Create AI Act. Yes, sir.
Fantastic. Just want to know, are you also working, I see DOE, are you working with Craig Martell's office? He's the Chief Digital and Artificial Intelligence Officer for the Pentagon. So are you all talking?
Yes, we are connected to them, and they actually there's some interesting opportunities, I think, on the workforce front. They're expanding their outreach to HBCUs. I think there might be some clear partnership efforts there. And then I'll also mention on the AI institutes, we've partnered with DoD on one of those as well. So to close, we see several kind of key challenges ahead that will need to be overcome so that we can kind of meet this goal of having a really vibrant, equitable, and responsible AI innovation ecosystem. So we have them listed here. There's always the challenge of funding levels. Every year we receive more well-rated proposals on AI that we can fund. And as Michael mentioned, the situation is being exacerbated by this higher cost for AI-driven efforts when they involve significant amount of compute or standing up of infrastructure. AI in education also presents a challenge just in terms of the depth and the breadth of the needs, from basic AI literacy to making sure that we have that strong STEM foundations at K through 12, to expanding undergraduate opportunities to more universities, and then retraining opportunities as well for adults kind of later in their careers. And we see significant work on kind of each of these areas to really make it so that there are pathways and opportunities into AI research, career paths, and jobs available across the country. We're also seeing a growing demand for the integration of AI into other domains of science and engineering. And we really see that that's what's going to be needed to really enable the potential of AI to accelerate the discovery process across these fields. And then, realizing that is going to require us to build more opportunities for researchers earlier in their careers to learn about AI techniques, integrate it into their work, and then also providing opportunities for researchers later in their careers to then kind of learn about AI techniques and opportunities. And then finally, there's just the pace of innovation. The field is moving so fast, and that sometimes presents a challenge when measured against our own kind of internal funding and decision-making processes, and really just making sure that we're funding the cutting edge from our side. So with that, we very much welcome the board's feedback on opportunities as we try to address these challenges going forward, as well as other ways that you see where we can strengthen our approach to fostering this AI ecosystem.
All right, thank you both. We've got 3 hands up. We'll start there. Suresh Garamella, Marvi, and then Suresh Babu.
Yeah, just to start off, we were hoping for an AI panel this time, and I understand we'll have one later, but you guys are just great. Great to hear from expertise internally, right? And division directors and ADs and all, I think you hold a lot of expertise, and I hope we, for future meetings, actually hear more from you. Because you have the pulse of where things are going. So I think this is great. Michael, I guess I want to hear about the doom and gloom too. There is a lot of concern in the community, and I have 3 short questions, maybe not so short. I'll ask them all. So if you could just comment on how you're fielding those, right? When you go to hearings and all that, these are real concerns. And so what is your general take on it? How complementary or coordinated are your efforts with the work being funded by other agencies? I guess how real is that coordination? And to Tess, I think I may have misheard you, but are you saying that some subset of GRFPs are targeted at AI, or is it a different pot of money supporting graduate fellowships in AI? So 3 questions, sorry.
Yeah, sure. All right. Can I hold the 3 questions in my head all at once? All right. So doom and gloom, I think that was sort of the setting for at least question 1. We actually had a doom and gloom slide in the slide deck. It was deemed too doomy and gloomy. But what I was going to say to the slide, I basically, in my travels, I've heard maybe 20 different kind of concerns that people have. They all come from kind of different directions, and they all have some degree of legitimacy to them. One of the reasons that I wanted to share this slide is because NSF is doing something on all those fronts, right? We're actually acknowledging these issues, and we're doing various things to help kind of intervene and at least increase our understanding of what goes on behind them. I like to think that the sort of my motto for this current AI moment is it's not as bad as you think. Which is to say that it's not bad. Like, there are some issues that we really have to be paying attention to, but I think a lot of times it gets very much overblown, and the questions are sort of like, well, wait, if we take this idea, this bad thing that happened, if we just projected it everywhere, then the whole world would end. It's like, yes, that's true, but no one's doing that. Like, no one's going to project it to that level. So at a high level, I just want to say that yeah, acknowledge that there are concerns, but also that we've just got this amazing nation of researchers who are engaged in these questions, and they're taking these things really seriously, and they're coming up with brilliant ways of kind of addressing them. So there's going to maybe be a little bit of turbulence at the moment, we hit a pocket of air, but it'll smooth out as people try to understand and come to grips with what the issues really are and how to do this right.
And I can speak to our integration with the interagency as well, and we're very much closely aligned with particularly NIST. If you read in the executive order, it gets a lot of tall tasks in terms of moving forward on AI safety, validation, and setting up that kind of infrastructure to do so. And they've set up they just announced the US AI Safety Institute that's going to be pioneering a lot of this work. And so we are connected with them because there are a lot of open questions in their research space that are going to need to drive those efforts as NIST tries to identify what are the best practices today, and then continually to integrate what the research community develops to the best practices of tomorrow. So one of the kind of concrete ways we've done this just recently is through the NAIR pilot. And we worked with NIST to scope the first call for access to resources through the NAIR pilot around trustworthy AI to really focus on the key questions that they are tackling through the AI Safety Institute, so that we are supporting the research and the connection of those researchers to the computational resources they need to move forward on those lines of effort.
The last thing was about the GRFPs.
Yeah. So on the GRFP program, it does support a number of students each year who are pursuing studies in AI. And then we also have the CS Grad for US program, which is a SISE-led initiative that focuses primarily on computer science and graduate degrees. So through both those programs, we're supporting advanced degrees in AI.
So if I could add one more thing. One of the AI institutes, the recent AI institutes, were actually funded by NIST and Law, Ethics, and Society from the University of Maryland. In this area, I think it's exceedingly important not to be arrogant about technology and science being the basis of solving these problems. It's to acknowledge the fact that we need these interdisciplinary social behavioral sciences, humanities, law, ethics, all of that being components of trying to find solutions. So what NSF is trying to do increasingly is to acknowledge that. And even within the agency, working across our directorates in conceptualizing calls, as well as intentionally building these kinds of institutes with our partners, so that we are actually tackling the problem. It is a problem. It is a problem. We acknowledge it, and we are trying to see what are the best groups we can bring to the table, what are the best disciplines we can bring to the table. That's what NSF ought to be doing, and I think there is a good effort in that regard. Thank you.
So maybe if I can jump in there, and then we'll go. Marvi, Suresh Babu, Scott, Matt, and Mel, you have your, okay. Which is, maybe I don't want to put words in Suresh's mouth, but I'll ask the question this way. In high-profile areas where there's a critical national need, is there potential advantage of allocating a subset of those GRFPs to those critical areas as opposed to an open call?
Yeah, and I think that has been done in the past where they've had call outs in the GRFP solicitation for those critical technology areas. So I think it is a mechanism we've used in the past in terms of focusing to advance in those critical technology areas. I'm sure the director.
No, I think we have done this. You're right. We have done this in the past. And one of the things that you will notice is when you look at the GRFP recipients itself, because the AI area is so hot, we get a lot more applications, and the outcome speaks for itself in terms of a lot more of those going to these areas that you would think that we need to prioritize, quantum or AI or things of that nature.
So my concern was just that AI is wonderful, but is it disadvantaging others, especially if it's not a stated goal that some of these will be given to AI, in which case it almost should be, partitioned off. So, we don't want to sort of behind the scenes prioritize or AI over other areas unless we say we are.
Right. And I think it's complicated, right? Because a lot of people are now saying they're doing AI that weren't doing AI before, right? And so we're trying to find ways of balancing like the people who are kind of core AI people who've been doing it for a while and making sure that they can continue to kind of create those foundations that other things are built on, but at the same time acknowledging this is really influential and important for other areas as well. And so we want to make sure that they're supported as well. And so it's been, it's a balancing act. I think that we're doing the best that we can.
Okay, Marvi, Suresh Babu, Scott, Matt, and then Mel.
Thank you for your contributions to the field and for your great presentation. So I have two questions. My first question actually has to do with product lifecycle, and I would say also data lifecycle. And so from an evolution of the technology perspective, there are two considerations that I have right now in mind, and that is the use and creation of energy-intense technologies, and also data pollution, software-created data that then you can't really distinguish really well with the tools that exist today from real data, right? And so I would call these both product life cycle, issues. And so my first question is, how are we dealing with those, right? And these are just two examples of those product life cycle issues. And the second question actually has to do with competition versus collaboration. Many of the I guess initiatives and efforts that we have put forward have to do with or would depend on high collaboration. But the way that we measure performance of both people and institutions actually lead to competition. So when you think about, cloud services, network services, open data, open knowledge, all of that requires a lot of collaboration. So how do you balance the two and actually create a culture within the institutes and within the community that leads to collaboration? So two very different questions. Thank you.
All right. So the two kinds of pollution that you mentioned are actually really interesting. There's the kind of physical pollution of the world using up natural resources, and then there's like information and data pollution. So one of the ways that we're thinking about the question of the actual environment is we've got a program in the SISE Directorate called Design for Environmental Sustainability in Computing, or DESC, where the emphasis there is partly on how can we make computations themselves more energy efficient, and that way we can scale them up without requiring so many resources. But that's actually been a fairly well-studied problem in computing for decades. One of the new angles is to think about the product lifecycle itself. The actual physical computers are also very energy intensive to create. And then if they're going to be replaced in a year and a half, 2 years, that's creating additional waste. So how can we actually be designing the computer systems themselves so that it is more of a sustainable process? So so we're funding people to work on exactly those kinds of problems. On the information pollution side, one of the things that we're thinking about is so large language models tend to be built by slurping up all available data, including the dirty data, the data that may have actually been produced by previous language models and therefore isn't really adding anything to the story. Ideally, we wouldn't be actually building these systems this way, that the large language models could potentially be built with a lot fewer language resources, in which case we could actually focus on high quality data and not just slurp up everything, including the sludge that was created in previous iterations. So one of the ways we're studying that is by looking at, for example, low resource languages. So not just English, where we've got tons of stuff out there, but like what's going on in Hawaiian? Like how do we build a language model for Hawaiian? How can we build language models for African languages and so forth? And so I think that's actually helping us get at least in part, at this question of what do we do when some of the information that's out there is really questionable. There's also questions of data quality and misinformation and so forth that are, some of these are actually very sensitive topics because one person's misinformation is another person's argument in favor of a different policy. And so we tread very, very lightly on that space, but nonetheless, there's really important scientific questions there and we try to engage with them as well as we can.
So I just want to remind us, we're pretty close to the end of this session. We have a NARE discussion over lunch. I don't want to shortchange that either. So please try to be brief.
So just briefly to your, competition and collaboration, I want to make sure we get to that question. So I think you've kind of heard of the ways that we structure some of these programs like the AI Institute. So each institute is actually a consortium of organizations. And then as the director said, they all have the mandate to reach out into their communities through educational opportunities, through community colleges and K through 12. And so we're structuring a lot of these opportunities to enhance this collaboration between the different institutions that we see as needed to kind of move the field forward. And then, as Michael mentioned, we're also seeing the field start to move forward in terms of this identification that they're going to need these kind of collaborative resources, and we want to support that as well in the future.
I have a brief question. Thank you very much for that. One of the things I really like about is AI for education. How are you going to make sure this data, which is used by these AI tools, are kept available for open and veracity is checked all the time? So that I checked many times, it doesn't agree with my own papers many times. So how do you handle this problem with that?
Yeah, and so this is a challenge that the whole AI community is kind of grappling with right now, right? In terms of the data sets that are being used to train models, if the data sets are found to have kind of faulty data in that, do you then clean them up? Then you have to retrain. And there's the reproducibility question. So there's many kind of open questions in this space around data. I see that the NARE pilot and hopefully the future NARE can have a really significant role in kind of bringing the community together to develop some sort of standards around and best practices around the management of these big data sets. Obviously, the pilot itself and then the future NARE will have a role in making available, open, high quality data sets for the research environment. But then I think it has kind of this underlying role as well as kind of building these community standards around best practices in AI data management and also best practices for when challenges have been identified with data sets, how to move forward as a community.
Thank you so much for your presentation today. Coming from the opposite side of collaboration, could you touch on your policies regarding access and security? Is this open to everyone? Is it limited to American persons? What's the policy there?
When you say it, you mean like the NARE?
Yeah.
So I'm gonna, if it's okay, just push that question off to the next session where we're gonna get into detail about that. But you would get to hear about details of the NARE that include all that sort of information. But very briefly, Tess will say very briefly.
Yeah. For the NARE, it's envisioned to be accessible for US-based researchers. So you have to be affiliated with a US organization, be it a research organization or a startup, small business.
And care is being taken on the security side as well.
I wanted to remind you, you do need to have one clear guardrail to avoid one pitfall. You alluded to it. It comes to decision-making, particularly decision-making, well, you called it societal decision-making, particularly things that involve political controversial questions. Because, of course, one of the big pillars you're doing is content recommendation and filtering, because what you put into AI determines what you get out. And as you said, Dr. Littman, about disinformation, the AI will have to decide what is disinformation or just disagreeable political opinions. And as you said right there, you should tread light on it. That research that we're talking about now, unfortunately, I think NSF cannot support at all. You can't tread there at all because of the problems with the First Amendment that many people see about it.
Thanks.
I just like to see the gloom and doom slide.
I'll send you email. Or maybe I won't. But no, I mean, it's stuff that you could, you just look at the headlines in the paper. Right? There's just a whole lot of topics that people talk about in terms of intellectual property, in terms of changing the way that education works, because now suddenly students can just ask the computer to do their homework for them. Like, what are the implications of that? All the way to, is AI going to rise up and just kill us all? Right. And so these are the sorts of things that are expressed. And I think all of them to some degree are completely overblown, but all of them have a germ of truth in it that we need to address.
And I think also a takeaway is that NSF is supporting work on kind of the technical side of these things to help develop the solutions in terms of content authentication and data provenance. So really kind of developing the best practices to try to address some of these challenges that are coming up in the ecosystem.